Complement was discovered many years ago as a heat-labile component of human blood plasma that augment opsonization of bacteria by antibody, hence the name complement. It is now known that complement system is composed of a large number of serum protein that play a major role in the defensive immune response. For example, complement protein can lyse antibody coated eukaryotic cell and bacteria, that is called cytolysis. Complement can mediate inflammation and attract and activate phagocytic cell. Generally, complement protein amplify the effect of antibodies, that is lysis of cell. The complement cascade is made up of at least 20 complement protein designated as C1, which has 3 protein subcomponents, C1 through C9, in addition factor B, factor D, properdin, factor H, factor I, C4b binding protein, C1 INH complex and S protein. The complement cascade is divided into unit. The first unit is recognition unit, which have C1, and then activation unit, that is C2, C3 and C4, C5, C6, 7, 8, 9 is membrane attack unit, and some factors that are going to the pathway in alternative pathway, factor B, factor D, properdin. Factor B is precursor of C3 convertase and factor D is cleaved for factor B to form active C3BBB in alternative pathway. Stabilize alternative pathway C3 convertase is properdin. Other factor H, promote C3b breakdown and regulate alternative pathway. Factor I that degrade C3b and regulate alternative pathway. C4b binding protein inhibit assembly and accelerate decay of C4b C2a. C1 INH complex bind to and dissociate C1R and C1S from C1. S protein bind fluid phase at C5b67 which prevent membrane attachment. Now C1 is divided into 3 protein subcomponent. Q is the recognition unit of C1 that bind to the Fc portion of antigen antibody complex, which may be a erythrocyte antibody complex, especially IgM or IgG. The binding C1q in the presence of calcium ion lead to activation of C1R and S. C3, which is further 2 protein subcomponent, is C3a is anaphylexation and immunoregulatory. C3b is the key component of the alternative pathway and major opsonin in the serum. C4 has 3 protein subcomponent which participate only A and B in the complement system. E is induced leukocytosis. C4a is for anaphylatoxin. C4b cause viral neutralization and opsonin. C5 has 2 protein subcomponents. C5a anaphylatoxin, principal chemotactic factor in serum that induce neutrophil attachment to the blood vessel wall. C5b initiate membrane attack. C6, 7, 8 and 9 participate with the C5b in formation of the membrane attack complex MAC that lies targeted cell. Now go with the classical pathway of complement system. Activation of classical complement pathway require initiation by the interaction of antibody with an antigen that is usually cell bound. The order is effectiveness in activating complement is IgM is greater than IgG3 is greater than IgG1 is greater than IgG2. However, some microbial products like lipid A of endotoxin and staphylococcal protein A or plasmin, a proteolytic enzyme that dissolves the fibrin of blood clot, may activate a C1 directly without antibody participation. Following binding of antigen to antibody, C1 complement component, which is composed of 3 proteins C1q, R and S, attached to Fc portion of antibody molecule through its C1q subcomponent. In the presence of calcium ion, a trimolecular complex C1qRS antigen antibody that has esterase activity is rapidly formed. The activated C1s subcomponent attacks and cleaves its natural substrate in serum C2 and C4 fragments. The release of C2 fragment traditionally has been called C2A. The activated C1 subcomponent attack and cleave its natural substrate in serum is C2 and C4. The release of C2 fragment, this lead to bind a portion of each molecule C2b and C4b. The release of C2 fragment traditionally has been called C2A. For consistency, this will label all larger complement fragments that are bound to the target cell as B fragment. Some book refer it will go to the A fragment. With the binding of 2B and 2,4, an enzyme with trypsin-like proteolytic activity is generated. A natural substrate for this enzyme is C3. Thus, it is termed a C3 convertage. Through the activity of activated C4b2b, the bar indicate an active enzyme complex. C3 is cleaved into a bound subcomponent C3b and C3a. A soluble component C3b then absorbed to bound C4b2b, forming the complex of activated C4b2b3b, which act as a C5 convertage and cleave C5 into C5a and C5b. C6 and C7 rapidly bind to the membrane binding site. Once bound to a membrane, this complex is stable. C8 and C9 then bind, forming the membrane attack complex. Activated C5b, 6, 7, 8, 9 that create a pore in the plasma membrane of the target cell. It is believed that the actual pore is a donut-shaped polymer of C9. The cell is eukaryotic. Sodium ion and H2O enter through the pore, leading to osmotic lysis of the cell. If the cell is gram-negative bacterium, lysozyme from the blood enter through the pore and digest the peptidoglycan cell wall, causing the bacterium to lyse. If a cell is gram-negative bacterium, lysozyme from the blood enter through the pore and digest the peptidoglycan cell wall, causing the bacterium to lyse osmotically. In contrast, gram-positive bacteria are resistant to the cytolytic action of membrane attack complex because they lack an exposure outer membrane, and the thick peptidoglycan prevent an attack on the plasma membrane. Now go with the alternative pathway. The alternative complement pathway play an important role in innate non-specific immune defense against intravascular invasion of bacteria and some fungi. The alternative pathway begin with the cleavage of C3 into C3a and C3b fragments by a blood enzyme. These fragments are produced at a slow rate and do not carry out the cleavage of C5 because free C3b is rapidly cleaved into inactive fragments. However, C3b becomes stable when it binds to the lipopolysaccharide of gram-negative bacterial cell wall to aggregate the IgA or IgE or to some endotoxin. A protein in blood termed factor B absorbed to bound C3b and is cleaved into two fragments by factor D, leading to the formation of active enzyme C3bbb. Active enzyme complex is sometimes called C3 convertage because it cleaves more C3 to CA and B. C3bbb is further stabilized by a second blood protein, properdin, and is changed into C5 convertage, that is C3bB, C3b activated. The convertage then cleaves C5 to C5a and C5b, forming C5b67 complex that possesses an unstable membrane binding site. Once bound to a membrane, this complex is stable and bound with C8 and C9 and form activated C5b6789, that is MAC, membrane attack complex. The Lectin complement pathway activates a C3 convertage by using a lectin, a special protein that binds to a specific carbohydrate. When macrophages ingest virus, bacteria and other foreign material, they release chemicals that stimulate liver cell to secrete mannose binding protein MBP. Because mannose is a major component of bacterial cell wall and some virus envelope and immune complexes, mannose binding protein to many pathogen and soluble immune complexes. MBP is an opsonine and directly enhance phagocytosis. The lectin also activate complement in two ways. After binding to the surface, it can trigger a alternate pathway directly. In addition, if mannose binding protein is bound to the MBP associated serine esterase, it activates classical component pathway. Thus, although the lectin pathway activates the complement cascade just as the classical and alternative pathway do, it uses a mechanism that independent of the antibody-antigen interaction, the classical pathway and interaction of complement with pathogen surface alternative pathway. Thank you. Don't forget to like, share and subscribe my channel.